particular video about how to use or manipulate the Docker images. Okay, how to create own Docker images. Okay, let us start.
In this lecture, we're going to see, and welcome to this lecture on Docker images.
Please let me know if voice problem is there anytime or you have any problem in viewing the content. Okay, don't hesitate to put that in the chat window sooner so that we won't waste time.
In this lecture, we're going to see how to create your own image. Now, before that, why would you need to create your own image? It could either be because you cannot find a component or a service that you want to use as part of your application on Docker Hub already, or you and your team decided that the application you're developing will be Dockerized for ease of shipping and deployment. In this case, I'm going to containerize an application, a simple web application that I have built using the Python Flask framework. First, we need to understand what we are containerizing or what application we are creating an image for and how the application is built. So start by thinking what you might do if you want to deploy the application manually. We write down the steps required in the right order. I'm creating an image for a simple web application. If I were to set it up manually, I would start with an operating system like Ubuntu, then update the source repositories using the apt command, then install dependencies using the apt command, then install Python dependencies using the pip command, then copy over the source code of my application to a location like opt, and then finally run the web server using the Flask command. Now that I have the instructions, create a Docker file using these. Here's a quick overview of the process of creating your own image. First, create a Docker file named Dockerfile and write down the instructions for setting up your application in it, such as installing dependencies, where to copy the source code from and to, and what the entry point of the application is, etc. Once done, build your image using the docker build command and specify the Docker file as input as well as a tag name for the image. This will create an image locally on your system. To make it available on the public Docker Hub registry, run the docker push command and specify the name of the image you just created. In this case, the name of the image is my account name, which is mmshad, followed by the image name, which is my custom app. Now let's take a closer look at that Docker file. Docker file is a text file written in a specific format that Docker can understand. It's in an instruction and arguments format. For example, in this Docker file, everything on the left in caps is an instruction. In this case, from, run, copy, and entry point are all instructions. Each of these instruct Docker to perform a specific action while creating the image. Everything on the right is an argument to those instructions. The first line from Ubuntu defines what the base OS should be for this container. Every Docker image must be based off of another image, either an OS or another image that was created before based on an OS. You can find official releases of all operating systems on Docker Hub. It's important to note that all Docker files must start with a from instruction. The run instruction instructs Docker to run a particular command on those base images. So at this point, Docker runs the apt get update command to fetch the updated packages and installs required dependencies on the image. Then the copy instruction copies files from the local system onto the Docker image. In this case, the source code of our application is in the current folder, and I'll be copying it over to the location opt source code inside the Docker image. And finally, entry point allows us to specify a command that will be run when the image is run as a container. When Docker builds the images, it builds these in a layered architecture. Each line of instruction creates a new layer in the Docker image with just the changes from the previous layer. For example, the first layer is a base Ubuntu OS, followed by the second instruction that creates a second layer, which installs all the apt packages. And then the third instruction creates a third layer with the Python packages, followed by the fourth layer that copies the source code over, and the final layer that updates the entry point of the image. Since each layer only stores the changes from the previous layer, it is reflected in the size as well. If you look at the base Ubuntu image, it is around 120 MB in size. The apt packages that I install is around 300 MB, and the remaining layers are small. You could see this information if you run the docker history command followed by the image name. When you run the docker build command, you could see the various steps involved and the result of each task. All the layers built are cached, so the layered architecture helps you restart Docker build from that particular step in case it fails, or if you were to add new steps in the build process, you wouldn't have to start all over again. All the layers built are cached by Docker. So in case a particular step was to fail, for example, in this case, step 3 failed, and you were to fix the issue and rerun Docker build, it will reuse the previous layers from cache and continue to build the remaining layers. The same is true if you were to add additional steps in the Docker file. This way, rebuilding your image is faster, and you don't have to wait for Docker to rebuild the entire image each time. This is helpful especially when you update source code of your application, as it may change more frequently. Only the layers above the updated layers needs to be rebuilt. We just saw a number of products containerized, such as databases, development tools, operating systems, etc. But that's just not it. You can containerize almost all of the application, even simple ones like browsers or utilities like curl, applications like Spotify, Skype, etc. Basically, you can containerize everything. And going forward, I see that's how everyone is going to run applications. Nobody is going to install anything anymore going forward. Instead, they're just going to run it using Docker. And when they don't need it anymore, get rid of it easily without having to clean up too much. Hello and welcome to this demo. In this demo, I'd like to show how to create our own Docker image for an application that we have. So first I'm going to explain a little bit about my application. So I have a simple web application which is based on Python Flask. It's on my GitHub page. It's a really simple application that just prints a message onto the screen. So how do you actually deploy this application? So there are some dependencies first. For example, there are some Python dependencies, and then you install the web application dependencies like Flask and the Flask MySQL Python dependencies, and then you basically run your application using the Flask command. And finally, just go to the once it's up and running, go to the website, go to the browser and access the IP of the host where it's running on, and go to the 5000 port, and you'll see a welcome message. So it's a simple application. If you ask how are you, it's going to come back saying I'm good. How about you? I'm going to show the code. It's just one single app.py file, and if you look at this file, all you have is a simple root, which is a default root that returns welcome message, and then another URL, how are you, that returns another message. So it's a really simple web application. So first, I'm just going to show how to deploy it manually. So what I would like to do is, I don't want to install anything on my Docker host, just I just want to keep it clean. I don't want to install some dependencies now and then, remove it later. So since I have Docker already, the easiest way to go about this is to start with some kind of a base operating system. Okay, so I'd like to start with a base operating system like Ubuntu, since I already have it, the image pulled. So I could run a Docker run Ubuntu, but what I want to do is I want it to stay alive, and I want to work on it, work on that particular container. So I'm going to append a bash command, so it runs the bash command when it starts the container, and I'm going to map the standard input using the -i parameter and the terminal using the T. So this way, as soon as the Ubuntu image starts, and it runs the bash command, and it takes or it attaches my input and terminal to that particular container. So that basically runs the command, runs the container, and connects me onto that particular container, which is all I want for now. And as soon as I exit the container, the image is going to stop. So this is all I want for now, just to play around and test my application. So I have my Ubuntu image running, and what I'm going to do is I'm going to follow instructions in setting up my simple web application. So the first thing to do is install Python. So I'm not going to install the remaining dependencies there. I'm just going to install Python. So I'm going to run apt-get install Python. It cannot locate the package Python. That's because you have it run the apt-get update to update the package index.
Yeah, I stopped video because I want to have a cross check. You are getting the steps up to this point, what the things are explained, or you have any doubt in any of the steps previously done in this particular video. Please let me know through the chat box whether you have understood what he is trying to do. So he is trying to create a Flask application. Flask is a web framework written in Python. So he has to install Python on his machine, okay, before he can install the Flask application. So what he is doing is, an existing Python container is there. So he is running that Python container using Docker run command. Ubuntu, so not Python container, sorry, Ubuntu container. He has that base operating system container is there, and he used two additional options over there. -it, that T stands for you want to attach a terminal to your operating system container, and I stands for interactive. So you want that container to have an interactive terminal associated with it. And what you are running inside that container was a command called as bash. So that is what these steps which are mentioned over here. I'll just go back one more step back.
We have it, the image pulled, and I'm going to map the standard input using the -i parameter and the terminal using the T.
See, this is the command that he was talking about, Docker run. So he want to run, okay, run what? The image Ubuntu. Ubuntu is a base operating system image. So in base operating system image, there is nothing, no software that actually runs on the image. Then what happens is you just get out of that image instantaneously as you run the Docker, because nothing inside that particular operating system is in execution. So I need to give some command that runs inside this particular operating system image. The command he is giving is this bash, or the born again shell. So he's running born again shell inside Ubuntu. Now I could have done with writing docker run Ubuntu bash, saying considering that my Ubuntu image will be containerized and bash will be running inside it, and it will run forever. But it doesn't happen like that. The reason behind that is born again shell requires a terminal attached to it. Okay, and by default, the Docker container operating system does not have an interface or a way to communicate with the external world. So I have to explicitly mention that I want a terminal attached to the operating system Docker. That I can do with option T. Okay, ठीक है. So I can write Docker run -t Ubuntu bash. इससे काम होगा, इससे काम नहीं होगा, क्योंकि इससे आपका bash तो run होगा, लेकिन bash will be having the operating system will also be having terminal, but bash can't interact through the terminal. So there's no connection between the bash which is running on the operating system and the terminal that is provided with the Ubuntu Docker using -t option. So I need to use that I option to say that I want this terminal to be attached to born again shell or bash, and that is why this particular -it option he is using. Now please notice that when he executes this, his prompt changes. Currently the prompt is of the host machine and his root user is currently logged in, and he is running a administrative shell. Hash जो दिख रहा है उसका मतलब है वो shell administrative shell है. Now when he executes it,
my application.
please see that his prompt has altered. Prompt has now this tag df916d and something. So this is the ID associated with the Ubuntu container which is running. So जो ID दिखता है docker/ps, docker space ps, that ID is reflected over here as a host name for that interactive shell. So this is an interactive shell to the bash software under the Ubuntu container which is running. So this is how these things are happening right now. Now what he's planning to do, he's planning to actually install a Python on this particular base operating system Ubuntu. In Ubuntu, if you want to install anything, the command is apt-get install. You might know or you might not know. Just if you do not know, just consider that using apt-get space install and the application name, you install that application on your base operating system. This is the CLI way or the command line way of installing a thing on Ubuntu operating system. But for accessing the remote repositories where the Ubuntu softwares are stored, like Play Stores में जैसे store रहते हैं software, वो connect करने के लिए you need to first run a command apt-get update. Once it is updated, then you can access it. Now only thing that I need to tell you about is whatever you are doing in this session, interactive session आप जो भी कर रहे हो, जब तक आपका Docker application run हो रहा है, it will be updated just when you kill the Docker session. So Docker stop से आप उस particular container को stop कर देते हो, तो जो भी updates आपने किए हैं inside the Docker container which is executing, they are lost. So you are just running a live session. So live CD mode में जैसे रन होता है आपका Ubuntu या कोई ऑपरेटिंग सिस्टम टेस्टिंग के लिए, वैसे ही यहाँ पे रन हो रहा है. तो जो भी आप फाइल सिस्टम में अपडेट्स करोगे, फाइल सिस्टम में नए फाइल्स क्रिएट करोगे, when you install a software, what you are eventually doing, you are creating certain new files in the file system, placing them in the requisite place so that you can execute them. Okay, that is what you do when you install some software. तो ये जो आप कर रहे हो, that is going to be remaining temporarily with this Ubuntu shell that you are running. But आपको ऐसा नहीं चाहिए. आपको आपका application जो है Flask application, उसको containerize करना है. तो ये steps जो ये बंदा कर रहा है, the instructor is doing, these steps are meant to be written down in a series fashion, in a linear fashion, and then converted into a file called as a Docker file. So that we will understand in further.
So
I hope this doesn't create any issues in understanding. मैं ज़्यादा explanation दिया क्योंकि ये due है, क्योंकि without that you might just feel these steps are mechanical. These are not a mechanical steps. We are doing this with certain thing in mind. तो ये step क्यों करा? This is like he is testing how to install his web application. That is what he is currently testing. Okay, fine. So we'll continue with this video further. I hope my explanation was